Okay, section 1.3. So several things here. A lot of this stuff we've already touched on, so I think it's going to be quite easy for you. But functions and their representations. So we'll get to the definition of a function here in a little bit, but let's get started with what we're talking about, different ways that we can represent maybe even domain and range, and we'll talk about those. So the first one is, can we connect inequalities with the number line with interval notation to show that how all of those are written? So for instance, if I had this inequality, so we'll say given x is greater than 4, less than or equal to 7, all right, something like that. So question might be, all right, can we plot on a number line, and can we give the interval notation? All right. So those are the two things I want to make sure that we can do. All right. So let's first get started. So what would this look like on a number line? Well, this would mean greater than 4 and less than or equal to 7. Now, what do you typically put on a number line if it's greater than or less than? If it's not equal to, what would you put at that point? If it's not equal to, you would put it open. What they do is they put a parenthesis. Okay, there's a parenthesis goes in hand with an open circle, but so we're going to put an open circle. I'll explain what they'll put on their graph. And if it's equal to, we put a closed circle. And then we would shade in here to show that this represents that inequality right there. So this is your inequality, right? We've got the greater than, less than. Here's your number line right here. So this number line, you would have it shaded. You would have an open circle at 4 and a closed circle at 7. Now, the open circle, you're going to see when we go to interval notation, we're basically going to write this interval here in a notation that it basically just gives this same representation. So what does interval notation mean? Well, this means we want everything from 4 to 7. Don't include 4, include 7. So if we're going to write interval notation, then all we're going to do is put the start and put the end. So we put the start, put a comma, put the end. All right. And then if we don't want to include, do you guys remember what to put on this? What do you do if you don't want to include something? You put a parenthesis. If you want to include, you put a what? Bracket. Okay. So this would be so here's the number line that we have. Oops. Here's the interval notation that goes with that number line. Okay. So just remember, an open circle is synonymous with a parenthesis. A parenthesis goes with an open circle. A closed circle, you would put a bracket. Okay. You know this is going to get filmed, and you can just look at the video. You don't have to take pictures.
I'm just doing it right now.
Okay. I'm just letting you know. All right. So let's look at another one. Okay. What if I had, I don't have a whole lot of room here, so say example 2. What if we had x is less than or equal to -3? So again, just let's do the number line, and let's do the interval notation. So why don't you try those two real quick? Number line and try the interval notation. So, Hank, how did you plot that on a number line?
I did -3 with a closed circle on it, and then shaded everything to the left.
That's right. So you just put -3, and just put wherever. Put a closed circle and then shade everything to the left. All right, then what did you get for your interval?
I wasn't entirely sure about
Okay.
this, but
All right,
negative infinity with a parentheses, and then -3 with a bracket.
all right, that's exactly right. So first thing is you always go in increasing order. So we will use the infinity symbol. So we always give where do we start and where do we end. Well, it's kind of hard to start at negative infinity, but we always just go left to right in increasing order. So you know that this goes from negative infinity to -3. We got the bracket on -3 because we can see that there's a closed circle there. So Hank said a parenthesis, and he's exactly right. Can somebody else maybe explain why you would put a parenthesis at negative infinity? Because there's not an open circle there, but what would be the reasoning? Yep.
So a closed circle would be, like greater than or less than or equal to, and since negative infinity isn't a specific number, you can't be
Yeah,
equal to.
you will never reach it, because if you say you're at negative infinity, then if I say -1, you're gonna go further, minus another one, you never reach it, right? So that's the reasoning. So bracket means include, parenthesis means exclude, or you can't reach, okay? All right, ready for one more? So I'll give you one more inequality. You see how this is maybe trying to just, it's basically taking what you see on the number line and putting it there. That's called integral notation. Okay. On this one, I'm going to give, I'll give you the inequality. You write out, so we'll call this one example 3. Same thing. So let's say you've got x is less than 2, or we put x is greater than or equal to 5. So first I'll plot on a number line, and then write in interval notation. Now, if you have more than one interval, it's okay. Typically, you'll separate those with a union symbol. So you put your first interval, put your other interval. The union means or. Okay? So in interval notation, you put your 2 intervals. Okay, so let's look at this. So obviously we're going to go to 2 and 5, right? And what am I going to put at 2? I can tell you right now, in the computer, I've seen them, they went ahead and made that a parenthesis. So just, if you see a number line, they're not going to use open and close. They'll put a parenthesis in a bracket. All right. Okay. And which way would I shade right here? Where for 2? To the left, and then we'd shade to the right of 5. So what happens is we get 2 intervals. I'm going to go ahead and call that negative infinity way out there. What's way out here? Positive. So what's our first interval.
Parentheses, negative infinity, comma, 2 parentheses.
And our second interval.
Bracket, 5, comma, infinity.
Okay, that's it. So is everybody okay with interval notation? Okay. And especially if they give you a number line, it should be easy to interpolate. Any questions about that? Okay. All right. Okay. Have you seen interval notation before? Good. Okay. Function notation and points. All right. So we have example 4 now. All right. Let me do this before I use function notation. So y equals 5 minus x. All right. So, first of all, what's the graph? What graph would that be? 5 minus x. What does the graph look like? Yeah. The other way though. It's negative slope, right? So first thing I would like for you to recognize is that that's a line. All right? How do I know it's a line? X is to the first power, linear function. Okay, so I know this is a line and I know the slope is negative. The 5 stands for what? All right, so yeah, this is of the form, if I just make it negative x plus 5, it's in the form mx plus b. M is the slope, b is the y-intercept, right? So we know the slope and we know the y-intercept. That's not the point of this discussion. All right, here's what I wanted to discuss. There's that. If I ask this question, find the y value when x is 1. Do you know what to do?
Yes.
Yes. What do you do? Plug 1 in for x and get your answer, right? Go ahead.
4.
Okay, I just wanted you to just do the work and not shout the answer out. Just do that. So you plug it in, right? Just to find the output, you plug your input in. So you would do 5 minus 1 and you get 4. So you know y is 4. So there's the answer. Well, we have a different way to ask this question that's a little bit simpler. So instead of me calling this y equals, I'm going to say f of x is 5 minus x. So now what I'm using is what's called function notation. You're going to say, well, what's the point of this? Well, I'm going to ask the same question here as I did on part A, but I'm going to ask it like this. I'm going to say find f of 1. So this is asking the same question as this. Just notice, oops. So here is the words I had to write. After I put find, I put the y value when x is 1. Right? Those are the words that I wrote there. Notice I put find, and then all I'm putting is f of 1. Okay? So, well, what did you do? You knew that you had to take your 1 and you had to plug it in. You described what to do. Well, since the 1 is in place of x, it's saying the same thing. That's your x. Plug your 1 in and get your y. So this right here is saying find the y value when x is 1. It's saying the same thing as this. It's just in a lot shorter notation. Okay? So that's what notation's for, is just a shorter way to write things. So then, okay, wherever I see an x, I plug in a 1, and I get 5 minus 1, which is 4. So f of 1 equals to 4 is what point? How can you write that as a point? Or as an ordered pair? 1 comma 4, that's exactly right. That means the point 1 comma 4. Very good. Okay. So that's all that function notation is. It's just a shorter way. So if I do part B, find f of 7, go ahead and And then once you get f of 7, write as an ordered pair. Okay, so what did you get? What's f of 7? Yeah, 5 minus 7, we get -2. And then what ordered pair is that? If f of 7 equals -2, then how can you write that as an ordered pair? 7, -2. So whatever's inside is the what, and your answer is the what? Whatever is inside is the blank value, your answer is the what? So whatever's inside is the x value, your answer is the y value. Okay. So if I did this, so one more. That corresponds to saying f of blank equals blank. Can you fill in the blanks? If I give you the ordered pair, can you fill in the blanks? F of 10 equals -5, because that's the x and that's the y. Okay. All right, I'm going to erase so we can get some room here. All right, so we've done the interval notation and the number lines. We've done your function notation and points. All right, so let's look now at plotting. What am I ready for? Example 4? All right, so part A, we'll just say given f of x is -3x plus 2, find 2 points and plot. Why for a line would I only say find 2 points? Why wouldn't I say find 3 points or 4 points? If I want to plot, why for a line would I say find 2 points? Yeah, that's exactly right. That's all you need, right? It's 2 points. So you only need 2 points, and then once you draw a line, right, that represents it. So find 2 points and plot. Okay. So write your function notation or write your points and then plot. And then after you do that one, you're going to do this one, given f of x is x squared minus 2. I'm going to give you like I'll give you the points that I want you to find. So we'll do f of -2, f of -1, f of 0, f of 1, f of 2, and then we can plot. Okay, so do part A. I'm letting you find any 2 points that you want and then plot. And then part B, I'm giving you the points I want you to find. Okay, let's do the line first. What would be two good X's maybe to plug in? 0 is a great one. So I would do f of 0. If you plug in a 0, what did you get? Sure about that?
2.
Oh.
3 times 0, 0, 0 plus 2 is 2. Then I would plug in a 1. And if I plug in a 1, negative 3 times 1 is negative 3 plus 2, negative 1. So now I got 2 points. So when you plot in My Math Lab, it'll let you drag the point. So all you're going to do, you'll just drag and put a point there. Then what's the other one? 1, negative 1, you'll drag and put your point there, and it will create the line between those points there, okay? You should be able to click on that icon. It should have a line there, okay? Everybody good with that one? Okay. So now on each of these, an easier way in order to write this, I like making a T-chart. So I could have just done the T-chart here also, where those are the X's, you plug in and you get your Y's. But we didn't have that, so it's okay. So you basically have 5 points that you're going to find. So if we look at the order here, we would do negative 2 squared, then subtract 2. So we get that answer. So let's do that first. So when you square negative 2, what do you get? When you square negative 2, what do you get? 4. And you're going to do 4 minus 2, and you get 2. There's that answer. So there's one of the answers. Okay. This is the, right here, this is for part A. All right. Plugged in a negative 1, so you do negative 1 squared minus 2. So you get 1 minus 2, which is negative 1. Okay. Plug in a 0. 0 squared minus 2, you get negative 2. Everybody okay on this notation and then what to do? And now we're creating a bunch of points, right? Plug in a 1. 1 squared minus 2, we get negative 1. Plug in a 2. 2 squared minus 2, we get 4 minus 2, which is 2. You could have also done this with a T-chart. So now we need to plot that. Well, what is an x squared graph going to look like? A U, right? A parabola. So let's look at this. So let's see. So I know I need to plug in, so negative 2, 2, negative 1, negative 1, 0, negative 2, 1, negative 1, 2, 2. So I have that right there. So anytime you have an x square, it's going to have that U shape like this, okay? All right. And again, you're not going to draw it out because you got the computer, so you should be able to pick some points, and then it should have that parabola icon that you use, okay? All right, any question with plotting points and graphing? You're not going to get anything kind of worse than this. So you have lines and it's probably simple parabolas. The only other one you'd have, the graph you might have is the absolute value. You know how to handle absolute value, correct? All right, everybody good with that? Any questions? I can't really tell your reactions because of the mask. Does this seem easy? Okay. All right. Let me ask you this. For these last three, real quick, can you just write the ordered pairs? So if it says write the ordered pairs, what you'll do, if it was just for those three, you'll put a bracket, and you put each ordered pair, and I think that they may want you to separate with a comma there, I don't know. You remember how it's picky? Do they want you to put another comma there?
They do.
Okay, sorry about that. So what would this first one be as an ordered pair? If I'm saying f of 0 and we got negative 2, what's the ordered pair for that? 0, negative 2. What's the ordered pair for the next one? All right, and then 2. Okay, everybody's good with that? And then you would close with the brace. So you use braces and you separate it with the parentheses in there. Okay. All right. So I think we're good with plotting. Any questions on plotting? All right. So I'm gonna give you a little bit more of a complicated function and I want you to find the outputs, okay? So I'll give you a couple here. So we'll just say example 5, part A, f of x is 2x squared minus 5x plus 7. Find f of 0, f of 2. Part B, g of x is 5x minus 3 over x plus 2. Find g of 0 and g of -1. All right, so for those, I've given you a little bit more of a more complex function. Find those answers there. F of 0, f of 2 on the first one, g of 0, g of -1 on the second one. Okay. Let's look at the first one. So we'll plug in a 0. Now, again, wherever we see an x, we should put our 0. So there's more than one x. And your answer for the first one should be what? 7. Very good. And then we do f of 2. So let's see, it'd be 2 times 2 squared minus 5 times 2 plus 7. So that's 8 minus 10 plus 7. What answer should you get there? 5. Very good. All right, then on the next one, g of 0, 5 times 0 minus 3 over 0 plus 2. So what answer? What do you get on top? What do you get on the bottom? 2. -3 over 2. Very good. And then the last one, g of -1. 5 times -1 minus 3 over -1 plus 2. You get -8 over 1. I didn't make a mistake. You just get -8. Okay. So just plug in, wherever you see an X, you plug the number in and get your output, okay? All right, last thing, just what's the rule of a function and how do we find domain and range? Okay, so that's the last thing that we're gonna do. Is that hard work?
Hey, you know that problem works with there in terms of the very next question, that's what I thought you was coming down with that. Look, genius is genius. Let me tell y'all, genius is genius. You either gonna have to figure it out that he's got it going on, or y'all gonna be lost. You with me? He's got it going on. Man worked the next problem and didn't even see the next problem. Look, that's almost like X-Men, you know what I'm saying? Sorry to interrupt.
No,
I just
you're
want to
good.
tell you.
Yeah, that's pretty good. I
No,
didn't
that's
have.
darn good, that's what that is, coach, you killed it. Look how many markers my man's got.
Oh, I know.
Look, it's like, let me just grab them and I can write anywhere. He'll be writing on the wall here in a minute.
Oh, I have.
Sorry to interrupt.
No, you're good. That's that right there. I'm drawing all the way up there. All right. So last thing, so what's the rule for a function? So I know you've heard this before. No, we're not gonna call this. What's our rule for a function? So the rule for a function is it's for every
Input has one output.
For every input, there is only one output. The other way, you know, you could say for your x value and the y value. Okay, so for every x, there's only one y. So if you look at a graph, there's what we call a vertical line test. That's the easy way to determine. So if we look at our parabola that we drew earlier, that was like this. Okay. So what does that mean? Well, if I draw a vertical line and it only crosses once, it's a function. So if I ever can draw a vertical line and it crosses more than once, then it's not a function. So vertical line test. So if you can draw a vertical line and it always only crosses once, then it is a function. Okay, so that's a good way to visualize it if you just look at the graph. Then I'll draw some pictures here in a second, and then the other thing that we want to look at is the definition of the domain is the set of all x's, or the other word is inputs, and range is the set of all y's, or the outputs. Okay. So I'm going to ask you for domain and range here in a second too. So I'm going to draw a couple of graphs. You're going to tell me whether or not they're functions. Okay, so just look at this. Okay. So you have 4 graphs there. We'll point to each one and we'll just say whether or not we think it's a function. So the first graph, does it look like it's a function?
Yes.
Second one?
Yes.
Third one?
No.
So here's why it fails. Right there, so you're gonna have 2 outputs for 1 input, okay, not a function. And then also on a circle like that, that's not a function. Okay, so this is a no, that's a no. Okay. So, everybody okay with just looking at the picture there and determining, that's the easiest way to do it is if you just look at the graph. All right, so, erase our goals because we've hit all of our goals for today, so. Now, if I give you a function that's a set like this, so let's call this, I think we're ready for example 5. So let's just say this is f, but I give you these ordered pairs. All right, so can you give me the domain? Can you give me the range? Then is it a function? Okay, can you answer those? So give the domain, oh goodness. Yeah, battery's running low. running low on the battery, so. Okay. So let's look at this. What's the domain? So when you write these domain and range, you're gonna write them as a set. So what did you guys get for the domain?
0, 1, 2,
Yeah, 0, 1, 2, 3. And what did you get for the range?
5, 10, 15, 20.
Yeah, 5, 10, 15, 20. And is it a function?
Yes.
Yes. So what, if you could add a point, so if we could add a point to this and make it not a function, so I'm gonna write down the same ordered pairs. I'm gonna have to stop the film here in a second because I've had trouble, my laptop's been acting up. Let's see what this says. It just won't charge. If it has an update, it'll just keep, it won't recharge until I do the update. That's just my, yeah, so I'm like 11%, I don't want to. Okay, if you could add a point, that would make it not a function. Could you add a point so that it's not a function? What would you do? So what has to happen for it not to be a function? One x with two separate outputs, so go ahead, yeah?
I was going to say like it has to have the same x.
Yeah, so could you make an example?
1, 6.
1, 6. So if you have that, that would be not a function because for the same x, we have different y's. So that would be a not a function, okay? All right. Last one here, trying to see if I can get this done before I lose the reason we wanted to study interval notation is can we, so if I give you this graph, I'm gonna go ahead and graph it here, it's like this. Can we do domain and range when it's not just points, when there's a whole interval of points, right? So if I look at this graph, I went ahead and drew the picture, it goes forever to the left and forever to the right. So there's no way to just list the points. That's why we want to know the interval notation that we looked at earlier today. So what would you say is the domain for this picture here? All real numbers, but we got to use interval notation. So we've got to do like we did today with the number line and all that I did at the start. So I can see that it goes forever to the left and forever to the right. So all the x-axis is used. Every x value gives you a point. So Allison's right, it's all real numbers, but what interval is that if you go from negative infinity to infinity? Negative infinity to infinity, and you put parentheses. So if I give you a picture, can you look and see what are the x's used? You give that. So why don't you guys try range? Now range is not going to be negative infinity to infinity. Range is what values? Y. So don't blurt the answer out. Just sit at your desk and do the work, and write the range in interval notation. Because I just want to give everybody a chance and then look at the answer. I'll just stop it after this. What we'll do is we'll take your questions on Thursday, and I'll film that way I'll film myself working the questions, so we'll see which ones, if I didn't get to something. That's just about everything. Okay. All right. So who wants to try the range? Who thinks that they know what the range is? All right, go ahead.
So bracket 2 and then negative infinity parentheses.
You got it right, you just got it out of order. So when we do interval notation, either go left to right or bottom to top, just go in increasing.
Okay.
Yeah, so you got the right answer. So she's right. So if you look, I can see that the graph goes down forever, and this is 2 here. So all of these y's are used, and that's negative infinity. So I just kind of think about what are the y's that are used. But most of us would say 2 to -50 because we look down, but we always want to go in increasing order. So you had it right. Parentheses at -2, I'm sorry, parentheses at negative infinity up to 2 bracket. You just put it like that, okay? That would be at the very end of the homework. There'll be a couple of those. If you have some difficulties with that, let's look at it on I guess, Thursday. So between now and Thursday, 1, 2 is due, I believe, tonight or tomorrow night. I can't remember. It's so much. It's due soon. This one I think is due Thursday night. And your test I pushed to tomorrow, correct? That should show up in there. Your test should be due tomorrow. Okay, I'm gonna go ahead and stop this. Good job, guys. It just